Hi dear children, today we are going to see the another one new topic, heating effect of electric current. When current flows through a resistor, some of the electrical energy delivered to the resistor is converted into heat energy and it is dissipated. What is the meaning of dissipated? It is wasted. Okay, so when the current flows through a resistor, some of the electrical energy delivered to the resistor and this energy will be wasted in the form of heat energy. And this heating effect of current is known as Joule's heating effect. So that heat energy will be wasted and this heating effect of current is known as Joule's heating effect. Just as current produces thermal energy may also use to produce an electromotive force. Okay, and this is known as thermoelectric effect. This is known as thermoelectric effect. Next, we are going to see Joule's law. Okay, so what is that Joule's law? If a current I flows through a conductor kept across a potential difference V for a time t. So now here we have to consider there is a iron bar and through that there is a I amount of current is passes through and we have apply a potential difference between the ends of the conductor is nothing but V with respect to the time of t. Okay, so now the work done or the electric potential energy spent is W, which is equal to VIT, because the current or if the charges will be traveling from one end to another end, so work has been done, so that work done will be denoted in terms of W, which is equal to VIT. In the absence of any other external effect, okay, this energy is spent in the heating the conductor. The amount of heat produced is, suppose if there won't be any external effort is applied, is not applied, then heat energy will be produced. So H, which is equal to VIT. Okay, VIT. So this is the amount of heat energy will be produced. For the resistor capital R, from Ohm's law. So here V, instead of this V, we have to substitute Ohm's law. What is that Ohm's law? I into R. So I into I square into R you will get. So this above equation will be rewritten like this, H, which is equal to I square RT. I square RT. Next, this relation was experimentally verified by Joule's, is known as Joule's law of heating. Okay, this above expressions, okay, W, which is equal to VIT, H, which is equal to VIT, and H, which is equal to I square RT. So all the three expressions will be verified by Joule's experimentally, and that's why it is named as Joule's law of heating. Now the statement of Joule's law of heating, it is states that the heat developed in an electrical circuit due to a flow of current varies directly as the square of the current. Okay, because from the last equation H, which is equal to I square RT. So what is that? IA? I is nothing but current, the square of the current, and R, resistance of the circuit, and T, time of flow. Okay, so by using that formula we can able to define the Joule's law of heating. And next, applications of Joule's heating effect. First one, electric heaters. So electric iron, electric heater, then electric toaster shows in the figure are some of the home appliances that utilize the heating effect of current. Okay, in these applications, in these appliances, the heating effect or the heating elements are made up of nichrome, an alloy of nickel and chromium. Okay, so electric heaters. So electric heaters, it is one of the applications of Joule's law of heating, right? And now, why we need to use nichrome as a heating element? What is the reason behind that? So all these instruments, nichrome is used as a heating element. Why they have used? Nichrome has a high specific resistance and can be heated to very high temperatures without oxidation. So because of this reason, we have used nichrome as a heating element. And next, electric fuse. In earlier we used in our houses this type of fuse carrier. Okay, this type of fuse carrier we used, and this type of fuse may used in the inverter sometimes in computer like this we have used this type of fuse. And nowadays most of the houses and buildings we have a circuit breaker. Okay, because here what is the main difference between these two? If here we have a fuse wire, when the fuse wire is melted we have to replace it, but here we need not to replace anything. Okay, so automatically the circuit will be open. After repairing that we have to uh, connect the circuit. Okay, right. Now fuses as shown in figure are connected in series in a circuit to protect the electrical devices from the heat developed by the passage of exclusive current. So we can ask another one question: why we need to connect these fuses in series? Okay, because when you connect in series the circuit will be open. Okay, when the high voltages or when the high current is passes, the wire will be, the fuse wire will be melted, so our home appliance will be safeguarded. Suppose if you are giving a parallel connection, what happen? Maybe this fuse carrier may be a fuse, but we have another path. Okay, so when it is a parallel we have another path. Through that path the current will be continuously passing, voltage will be passes through, and because of that the home appliance will be damaged. To avoid that we have to use a series connection. It is a short length of a wire made of low melting point materials. It melts and breaks the circuit if current exceeds a certain value. Okay, so if it is exceed that particular value, then the wire will be melted. So the wire, it is made up of lead and a copper wire, melts and burn out when the current increases above 5 ampere and 35 ampere respectively. If it is exist more than 35 ampere, then automatically the wire will be start melting and the home appliance will be safeguarded. The only disadvantages with the above fuse is that one fuse wire is burnt due to exclusive current. They need to be replaced. So once the fuse wire is melted, we have to replace it. Nowadays in homes circuit breakers, we called it as a tripper. Okay, circuit breakers are also used instead of fuses. Whenever there is a exclusive current produced due to a fault wire connection, the circuit breaker switch opens. Okay, circuit breaker switch opens. After repairing the faulty connection, we can close the circuit. We can close the circuit breaker switch. And next, third one is nothing but electric furnace. Okay, furnace are shown in figure. Okay, it is used to manufacture a large number of technologically important materials such as steel, then silicon carbide, quartz, then gallium arsenide, and etc. Okay, molybdenum nichrome wire wound on a silica tube is used to produce temperature up to 1500 degrees Celsius. Okay, so this is the combination of an alloy. Next, a carbon arc furnace produce temperatures up to 3000 degrees Celsius. Okay, next, electrical lamp. Okay, it will produce a high temperature. Right, next, electrical lamp. It consists of tungsten filament. Melting point of the tungsten is around 3380 degrees Celsius, kept inside a glass bulb and heated to incandescent by current. An incandescent electrical lamps, only about 5% of electrical energy is converted into light and the rest of is wasted as heat. Okay, because if you switch on the tungsten it will be very hot, the room will be very hot. Okay, electric discharge lamp, then electric welding and electric arc also utilize the heating effect of current as shown in figure. So now this is nothing but the tungsten bulb. Okay, tungsten bulb we used in our daily life, maybe in our houses. Next, electric arc. So like this the arc will be produced. Like this you may see some of the comic and some of the films also. And this is electric welding. Okay, we call it the arc welding. Okay, so in lathe we have seen this type of welding machines. Okay, so these are the apparatus. Okay, thank you.